If it says it's going from the left, and that means you're starting on the left, going to the right. I think you end on the right. Kind of like if you read from left to right, start on the left, end on the right. You will all be very happy to know that I think I figured out the key to my golf swing.
What was it?
It's actually the feel of the club, not the toe of it.
I'm so excited for you, Mr. Gill.
Probably.
You're literally about to be like Tiger Woods. What's that?
I have to check. I had to try it out and then I can get balls in it. Maybe Friday. I'll give you another minute. Again, this stuff is the easy stuff. It is your exit ticket though, so you need to make sure you have it down. Oh, you have two deadlines. I think I forgot to mention this. You have two deadlines this week on Friday. And if you got 40s, you also have to tutor before them. So you're pretty much out of time if you haven't made plans to tutor. Hopefully you don't have a 40 on both of them. It's definitely my favorite.
Why do you sound like that? I say my face stuff.
I don't know about doing that. That changed my voice. Brian's hanging in there. Brian, you look like one of those puppies like on Facebook that's trying to stay awake, but you fall.
Puppy conversation.
You just look just like that. Yeah, we've given up on Jacob. But you're hanging in there. Trying. Jacob, please. Jacob. All right. I'm not going to do these up on the board. They're not hard. What'd you get for number one? Is it an enlargement or a reduction? But enlargement, what's the scale factor? What's number two? Enlargement or reduction? What's the scale factor? Make sure it is less than one. If you ever say reduction and the number is not less than one, you did something wrong. Either it's not a reduction or you have the wrong math. You probably put the wrong number on top and the wrong number on bottom. What's number? Oh, wait, it was 1/2. You didn't hear that from me. So what is number three? Enlargement or reduction? What was it?
Reduction.
Who just said 2/3? Is it 2/3? Oh, yeah. So you need to be able to simplify a fraction.
Wait.
So the numbers are 6/9, but you will never see 6/9 on a multiple choice test. It would be reduced to 2/3. Again, it's a good idea to know how to do all I don't care. I'm more thinking of the EOC and the district stuff. My guess is they're going to use a simplified fraction. Of course. Again, I don't get to see the EOC, so I don't know how they do their multiple choice answers typically, but my guess is 2/3 would be what
Simplified.
You mean how do you simplify a fraction?
Yeah.
Like 6/9? Because it's 6/9, right? It's 6/9. No.
And then the top divided by bottom.
I hate it when you guys say, right? You guys love keep change flip, by the way. Oh yeah, I did do keep change flip. I did not. What did you say?
Top divided by bottom.
Well, that's changing it to a decimal. She wants to know how to change it to a simplified fraction. What do I do? You say, well, what? And you preferably, you say, what's the highest number? You Googling it?
Yeah, I was checking.
Yeah, Googling it. You say, what is the highest number that will go into both of those?
8.
3. I hope Google. 3 will go into 6 twice. So 2/3.
Oh,
I know, like back to elementary school stuff, right? Now here, I'll give you a hint. What about this? 10 does not go into 36 or 96. So here, let me just tell you one thing that will work. So don't sweat it. Don't worry so much about the number you initially tried.
Top was 12, right?
What number do you know? Well, but it's got to go into both of them.
You just got 5.
Well, might actually. Yeah. Well,
Yes.
so, what's true about both those numbers? They're both even, right? What number goes into every even number? You can always, if they're both even, start at 2. 2 goes into that, 48. Are they both even still? Do it again. 2 goes into that. And 24. Now 2 won't work, but now go to 3. If 2 doesn't work, just go to 3. Just 3 go into both of those. It does, right? It'll get you. You can't mess up, as long as you do your division. So don't worry too much about, I don't know how to simplify. I mean, just try 2. 2 doesn't work, go to 3. Now, if 2 didn't work, 4 is not going to work, right? Because 2 is a multiple of 4, so you don't have to really try 4. So if 2 doesn't work and 3 doesn't work, go to 5. 5 doesn't work, then you go to 7. You don't need 6 because if 2 and 3 didn't work, 6 ain't going to work. So then go to 7 and just keep doing that process. It doesn't take you that much longer. I mean, if you know the highest number immediately, then you can do it. All right, so that's pretty easy. That's your exit ticket, something like that. I don't know. I could have you create a new figure. Like I could give you a small triangle and say, what would the lengths of the sides be if your scale factor was 1.5? So you just multiply every side times 1.5. So again, since I'm recording. So just in case I do that, because it's not that hard. So I say, I want you to tell me the length of the sides of I actually think this is easier. The lengths of the sides of that triangle if my scale factor is 2.5, 2.5, whatever you want to call it. 2.5. Yeah, you just multiply every side times 2.5.
Oh.
Yeah. So you get 2.5. What would that be? 4, 5. Oh, yeah. And then 3 would be 6, 7.5, I think.
Yeah.
So you just multiply by. Remember, we're always multiplying the scale factor times the original size. Length of the original size. Is it Isaiah's day? Isaiah's day. Thank you. It's a red day. They both get that. I think you day, I guess 30 days. All right, so that could be on there. So again, just understand I'm figuring out what number times these gives me these, or if I just give you the scale factor, you're just multiplying that times that to get that. All right, now it gets a little trickier. So look at that example in the book. I think it's the next one. Oh, just wait till we get to the last.
Oh,
This?
what? Why?
Good to go.
What are these?
Hold on,
Ew.
I'm zooming out.
You speak in riddles and then you throw this.
So it is the one that has that figure on it. Oh no, it's like the next page. 7.
It's gonna be 6. But that one.
No, this is an example. This is not a practice problem. It's an example. We're doing the lesson still. It's an example. I'm sorry, not an example. It's the concept. It's the lesson basically. I'm pretty sure it's 7. The back, literally the back of the page you were just on, the first page. I think. Do you have the first page in your right hand? No, that's it. What? It's 79. Oh. 7, right? That's bottom of 7. Down the bottom of 7. Wait, what? Add in. Right there. Page 7. It's not an example. It's the lesson. So don't look for example. Look for that picture. Page 70 bottom. So we are now going to be doing a scale factor and creating a new image, but we're doing it on a coordinate plane. Let me check it. Now, it's not very difficult at all when we do it from the origin. So on your quiz, this will not be exit ticket. It will be on your quiz. On the quiz, though, I mean, I expect everybody to get this right. If I am starting at the origin, what's the origin?
0.
0, 0, right? So we're starting at 0. So let's do, this is not about the lesson today. It's a reminder of what we did before. How long is that line take?
8 minutes.
No problem, right? Oh, didn't do that. Actually, too, let's do this. Oh, I don't know. How long is that line segment? 5 units, right? Not 8. Right? Why isn't it 8?
It didn't start at 0.
It didn't start at 0, right? So when we start at 0, it's pretty simple because we don't need to take some other stuff into account we'll have to take into account later. All we're doing, and I think, yeah. So is this an enlargement or a reduction? Look at the symbol, the way the letters. Yeah, we are going from the letters with no little prime marks to the letters with the prime marks. So that's how you know it's an enlargement. So what's our scale factor got to be? Not a specific number.
Not to this big.
Got to be over 1. So we know that. How much bigger than 1 do you think that have to be? Like what's the scale factor? Just tell me what the scale factor is. How do you know that?
By counting the units on the.
It's the same thing we just did. It is the same from the standpoint of how big the new figure is. It's the same thing. If I know this side is 1, and I know that side is 3, we use the same formula we just used. I only need one side that I can use. Scale factor is always the same. So the final image divided by the pre-image is 3. So we know the scale factor. So that's one question you could get. What is the scale
Factor.
I'll just get rid of all of that and then rewrite. So, one question on a coordinate plane, again, pretty simple. Now, if none of the sides are along grid lines, like if I gave you this triangle, here, here, and here, now you can't count. That gets a little tricky. And we're going to go over those. That's still going to be on the quiz. So we couldn't just count left and right in that one because none of the sides of the figure went right along grid lines, and you can't count straight diagonally to figure out length. But for now, we'll do the simple version. So if I know the scale factor is 3, there's only one other piece you would need to do, because remember, you would not have this image. It would more likely be telling you create an image from this pre-image with a scale factor of 3. But let's talk about how that would work. So now again, just imagine what color is that? Maroon. So I was going to go. So imagine the maroon is not there. That's what we are creating. Here's your process. You need to know what is every egg. I want you guys, I should have done this for the other class. I did for them. I remember halfway through, I'm not sure everybody knows how to figure out what the X and Y is. I want you to create for the original image, or not create, but just write down what are the ordered pairs. So what is the X and the Y for all of those points for the smaller blue triangle?
Another exit ticket question.
No, this is a quiz question. Exit ticket is just what we did before, the scale factor.
Is that one of the first 2 or no?
This, normally if I do an exit ticket on it, I don't put it on the test because you've already been assessed on it. And that saves me from having to put one extra question on there. That's how I'm hopefully going to be able to give you more free retakes, is by not having to put as many questions on there. So I want you to write that first. Okay, well, I'm going to fix this a little bit while you guys are doing that. Trying to do this. Yeah.
Just to go, we can't see.
Yeah, I know. You think?
Well, if you do.
Yeah, you would think, right? Very important though. I know I'm funny. You guys may not always see it. I can zoom in. So here, I just want to be able to put them side by side. There we go.
What are we?
Can you still see?
Yeah.
What are we doing
You
again?
can see.
I made it. I'm gonna zoom in though so you can see.
Maybe you should make it this.
Are you sure that's this one?
Doesn't matter.
Nope.
Fence.
I wish. I would like to go. I like Latin.
I don't know if I
want to make it.
I did, I did.
What do you mean the order pairs? Like,
Like,
of both of them?
maybe like this small board, a little too big.
Yeah, it's a little too big.
Well, it was already up there. It's in your book.
No.
The picture is.
You hear me?
No.
What are we basically finding out?
Right now, you're just writing what are these, what are the pairs. We already do.
All
I mean, if you know what to do next, you can. But I'm taking baby steps. Let's. There. We go. Ah. For some reason, it does not want me to show the rest of it, so you can see it in your book. I'm not able to get rid of that at the bottom either. Here, let's see if I can. Never mind. Ah, that's bottom. Oh, wait, I know how I can fix it.
Don't you have to do it for both? Both images?
There we go.
Don't we have to do it for both images?
Do what?
I know. Like just how we did it for the
Yeah.
drawing.
Yeah, well, you're given the. This would be, remember, we're acting like this is not here. This is what you would be creating. So you're given these, and then what would you need to do? What is this? What is the scale factor? We said 3. Oh, yeah, 3, right there.
You would just find.
So if I tell you that, so again, let me just rewind. So I can tell some of your probably didn't get this the first time I say it. We would not have this in it. I would give you this. Here's what your problem would look like. Let's just do this. Now you'd be able to see the graph. That would not be there. None of that. I give you the image and I tell you create from the pre-image. Create. They would really just say create an image from the pre-image that has a scale factor of 3. That's what you would get on the quiz. You know it's got to be bigger. And what would you know about the sides? They would have to be how much bigger? Yeah, so we would say, well, I know this bottom side, because again, I can just count these. I know the bottom side of the figure is going to have to be 3. I know the left side of the figure is going to be what? Yeah, 2 times 3 is 6. So I know really how big the figure is going to be. I just need to know where the figure is going to land. Because we're doing it from the origin, which is the tricky one. It's actually not.
Why don't you just take 3?
That's all you do. You just take, well, what, okay, so let's go back to this. What are the ordered pair, or what's the ordered pair for P? I'm going to call them that. Dave, what's the ordered pair for P? You sat there and absolutely nothing. All right, so guess what? You don't get off the look. What's the ordered pair for 3? For P? How do we find, what's the first value in an ordered pair? One of these. First value in X or Y. Yes, 50-50. X. It is X. Alphabetical order. The easy way to remember. So my first value in an ordered pair is always the X value. Which axis is the X value? Left and right or up or down? Left and right. So the way I find my X value, this may or may not work. Okay. So the way I find my X value is I just
if I'm trying to get to Q, I just go right. The way I find my Y value is in this case, I go up. So my X and my Y for that are just 1, 1. You got to know how to find a point on the graph. I don't know. I mean, frankly, I don't know how you're going to graduate high school if you can't find a point on the graph. The odds are you haven't passed your algebra EOC yet.
Wait, that's for you.
Oh, I'm sorry. Good call.
You just made me so.
Well, I'm glad you guys are paying attention. So I would go again, same concept of going to the right one, but 1, 2, 3 for P. So Q we just did. So again, right 1, up 1. And then R, right 2. Again, always left and right. Then up or down. 2 and 1. So again, make this note in big capital letters. So when you are creating, and again, I'm going to say final image, just know it's not going to be called final probably. They're just going to say image and pre-image. Well, this is pre, this is just image. I just feel like people are going to be confused, and I'd rather you understand it right now and worry about figuring it out in the EOC later. All we do is we multiply every single number by the scale. I say, how do you do that? If it is from the origin, only from the origin does this work. Because remember, when we start at 0, the length of the segment was just that number.
All right, now.
So we don't have to take anything weird into account. So I multiply all of these numbers times the scale factor, which I gave you there.
Which
So that would be where we would draw the figure. Those are our new points, final points. And now I can erase this and show you
That's where you create.
that that's exactly where that image is. So again, P is at 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9. Q, 1, 2, 3, 1, 2, 3. R, 1, 2, 3, 4, 5, 6, 1, 2, 3. And we said we could also kind of just confirm that the length of the sides are in proportion. 1 times 3 is 3. 2 times 3 is 6. So there's a whole bunch of ways to do some of these. I'm not going to teach you the formula way. I frankly don't even know if that would last through my quiz, much less all the way to the EOC. So we're going to try to intuitively learn how to do all of the stuff that's on the coordinate plane instead of just plug numbers in. Okay. That's not mine, but thank you. No, again, no, until somebody comes back to me and says that they got stopped, I'm not worried about it. All right. Any questions on that? About to get built up. All right. You good, Vicky?
Oh yeah, obviously.
Great.
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 I'm quite conscious right now. but-
All right. Oh, let's not tackle that one just yet.
I told you she's awake.
Why did that happen? That is not. There we go. That's better. I know, right? Let's do this. This will be faster. I think it is.
If you eat a lot of those, it's actually dangerous.
Oh, really? Is that what you think?
Yeah.
Is that, are you concerned about me? And where did you hear that from? All right. So I'm going to draw a new triangle. We'll come back to that triangle. That's way more difficult. So let's start with an easier one. I will use the new not new, but use the new tool. So we're going to go, I don't know, we'll do this one. So there's my triangle. Let's make it pretty. Whoop. There. What color do you want? I don't have a lot of great pink options.
there's a pink right there.
Green, red,
It's pink.
orange.
Yeah.
Orange.
They said pink first. You gotta be faster, man. You gotta be faster. All right, so if this is my original, somebody made a lot of money just by putting pink on things.
Exactly.
And I tell you, the scale factor. So we're no longer doing it from the origin. So we'll get to this problem in the book in a second. I'm gonna. All right, scale factor of 2. You just do the book one first. No, all these are dilations. Yeah, translations. There are going to be some problems. Probably you'll see on the district stuff where you do multiple things. I'm hoping you remember enough about the other things to do rotations, translations. If we have time, maybe we'll throw that in. But so what is one thing? So this is the kind of question you might get to the points you need to pass. Again, there'll be some easy questions, 1, maybe 2 easy ones. You get both of those right, then you got to do one more thing correct, answer one more question partially correct, or if it's an easy question, get that question correct to pass. What's one thing you can tell me is going to happen with this? It's going to get bigger. Now, that probably wouldn't be a question, but more specifically, what's going to happen? More specifically, there's one easy thing.
It's gonna stay on the origin.
No, it's super easy. So easy, you can't even figure it out. Has to do with numbers.
It's getting bigger.
How?
It's gonna get bigger.
Numbers.
The numbers are getting bigger.
Numbers.
It's gonna start getting
Numbers.
positive.
No, I haven't heard nobody say numbers.
More positive.
Use numbers.
2 times something.
Not 4. No. So one thing we could do is coordinates, right? Do something with coordinates on there. Around the origin, that would work, but this is not going to be around the origin, so won't help you as much, but there's still one easy thing. This is a connection you got to make when you're doing dilations.
It's going to be so
Curious how you got 8, but no 8. No negative. Can't be negative. Nothing can be negative later. Yeah.
yes or something.
So what's going to happen? What's going to happen from the original, from the pre-image to the image? It's going to set it by millions. So it's going to get bigger, and the factor is by 2, right? If only we knew how long one of the sides was to know how long the new side will be. Somebody just said. Thank you. I know how big this side is right here. Swear.
Oh.
Where nobody made that connection. You just did.
Oh.
So I know the left side, because it's not going to rotate or slide or any of that. I know the left side of my new triangle better be 6 units long. So here's the trick. Or not the trick, but the next level. We're leveling up. Oh, we got more levels after this. You're going to be writing me so many notes on this.
Are you
So,
are we gonna let me guess, are we gonna have to translate it to the actual graph or something like that? I don't like the science.
I'm not well, I'm silent because I'm not sure what you're asking. We're on a graph right now.
Yeah, but I know actually translated like
People
rotation and
that's
stuff. Like temperature.
Oh, no, there's no rotation or any of that kind of stuff. No, we're using just this.
Okay.
So here's the new level that we're going to. I want to dilate this image. Not around the origin, so tune in, because this isn't where, ladies, tune in. About to get real. I'm going to dilate this around a point on the image. So here's and again, there's 2 things all of you should be able to get when we dilate around a point on the image. One is something like this, how long a side is still going to be if it's an easy side to figure out, which I'll I'll probably give you one each. You can tell me at least one thing. The other thing you need to think or be able to figure out or tell me, if we are dilating, so write this in. If we are dilating around a point that is one of the, again, vertices, that's the correct word. You could just say one of the points on the image, one of the points of the image. If that is the center of dilation, that point doesn't change. Again, you got to use your own words. I'm going to show, let me just show you, just watch, and then use your own words. So I'm going to take this and I'm going to create a B prime, an A prime, a C prime. A prime is the exact same as A. If that's where if that's the center of the dilation, they're the same point. It doesn't change. So you better know that. No math involved, just a concept. If that is my center of dilation, it's the same point. The beginning point, same as the end. So it does not change. It's kind of like it sort of grows if it's an enlargement. It grows out from that point. So it doesn't change. If this is where I'm going out from, I don't change that.
Yeah.
What? You explain. Well, you just said I'm making it a riddle, so you clearly have it.
You just continue.
Well, I don't know of another way to say it. Well, again, you need to understand what's happening to the other 2 points as well. That's your A is done. I'm done with A. I'm not adding it. A doesn't change. Now we're moving to B and C.
Okay.
B and C grow out from A, right? Because I'm enlarging.
What definition is it?
Can I say what I write down?
Yeah. If you want to share, always, yeah. Because again, you need to use your own words anyway, not my words.
I said if we're dilating around the point won't change. Starting at the point will go out or in. Because if we start at the
So
point,
the other points, again, if we're enlarging, the other points will extend out. Now, if we're doing a reduction, then the points kind of pull in toward that center of rotation, like it's a black hole. If we're doing a reduction, then B would slide in toward A, C would slide in. It would have to stay along the line. You never create new lines if one of the points of the image is on it. When we draw the new image, we will trace right back over that line and right back over that one. We're just changing the length of those lines, and in this case, we're changing them by how much? Yeah, if you don't remember,
2.
scale factor was 2, so we're just making them twice as long. So again, if it was a 3, we'd be making them 3 times as long. So we already said how long the left side should be, right? How long is the left side then?
6.
So again, this point doesn't move. So I just create a left side that is 6 units long from it. 1, 2, 3, 4, 5, 6. Hopefully this.
Doesn't ruin the pink.
Okay. Well, I was more worried about it moving in. 4, 5, 6. So that's my new left side. The yellow is my new left side. It will still start from the original, or not original, from the center of dilation. The left side needs to be 2 times the length of the original side. Here I can write out here. So that left side is 6. The original was 3. Now, if we didn't have a side along grid lines, it's a little tough. For example, I gotta somehow, so my new point down here, pretty easy, that's B prime. Problem is I need one more point. I really just need one more point. I don't need to extend both sides. Like I don't need to extend, I just need to extend this out and then I can just connect.
But it. That is.
I'd say it again now.
Like do you know how you did that first point, right? B.
Oh.
Move that, right? Wait, no, you moved A. You put B to that one.
No, I didn't. I moved B.
No,
you moved
no, A's at the top.
A doesn't move. Remember, that's what we said. The center of dilation does not move. It's the same. So and again, this is what you should know. If you know nothing else, and I say the center of dilation is this point, you should be able to tell me, oh, well, then the new point is that same point. Like at the bare minimum, that's what you need to get. And you should really be able to tell me how long a side is or something if I ask that. How long will side A be? Well, that would be 2 times as long. In this case. Oh, scale factor was 2. So how are we gonna, like, what would we do? We need to make AC twice as long, just like we just made AB twice as long. How in the world do we do that? What? I told you before, UC coordinate plane, that's what you're gonna be using.
Of course it is.
Well, but we're not. That's the only thing. We're not gonna use it.
What?
It's what you should use, but it's really complex. So I'm gonna show you an easier way to do it. I'm giving you an easier way to do it. What's gonna happen to this line? That line, I don't know how long that line is. I could do distance formula, but problem with that is I don't even know what this X and Y is to be able to do distance formula. Well, but I do know one thing's gonna happen to that side. What's gonna happen? It's gonna be twice as far, right? Oh god, this is not an easy one to do this with. No, we're gonna do it. So I'm gonna give you an easier one on the quiz, and we'll do it. There's one easier in the book. This line is still gonna go straight, right? I told you we don't change that line. So if I extended that out, you'll never have to do this. I made this one harder than I. Oh, here, let's do this. This will be easier to see. That's pretty close. I need to figure out what is this length double. So I'm gonna have to kind of estimate. I would normally give you ones where it landed right on X and Y. So I go down 1 and then we'll just say a half.
Yeah, right.
So the key is I'm going right 3. That's the key. That I know is correct. So then from this point, I go right 3, and then I just need to go down to the line because I have to be on the line, right? We said the line's not going to change. That's my new point. Well, again, it's not this line. It's not straight. It should have been higher, like not perfectly drawn. So that's all you have to do is count. You don't have to do the distance formula. You just double, basically, what if it's a factor of 2. Now, if it's a factor of 3, I would have to count farther. So now I can say this length. So here's where it gets a little confusing. Well, some of you are already confused. 1, 2, 3, 4, 5, 6. Because my original one was 3, so now I need a total of 6 going from A. We always start from the center. My down was about 1.5, so 1, 2, 3. Again, as long as you have this correct, then you just have to run into the line, basically. Oh, so that's how you get to the point. You don't need to do distance formula. You can just kind of do hops left and right or up and down, and then double those or triple those or cut it in half or whatever you need to do, depending on what kind of dilation it is. All right, so now let's look at the one in your book. I don't know if I moved it over into. Yeah, here we go. All right, so let's walk through this again. Wait, that's the same thing. No, did I not put it in here? Oh, I guess I did it. So look in your book, I guess, and I'll draw it up. Page 71. So again, it's not the example. We'll get to that in a minute. It's the lesson part. Actually, tell it. Let me copy it and I'll put it in here real quick. Yeah, here it is. Oh, I don't know if this is gonna work or not. Maybe if I take the picture really quickly. Yeah, okay, there we go. I think, oh, I didn't get the 0, but that's fine. That's fine. Ah, there we go. So this is in your book. Oh. Ah, why is it not working? Dang it. There. Ah.
Yeah.
Why does it keep doing that?
That is actually on our mind.
Oh, here, let me zoom out. I don't know why it keeps doing that and not sliding it. All right. So again, they are to now. What's my original image in this? We're doing a what? So again, make sure you don't just assume that we're going from little to big. And this one, these points, the blue, is my original image. We're doing a reduction. So in a reduction, it's like we're sucking the two endpoints down into the, oh, and D is the center of dilation. So it's like we're pulling those two endpoints in. But all the other stuff still applies. We're going to take the scale factor, multiply it times the length, and figure out how long the new length would be. So if I have an original length of 4, it says the scale, this is all in your problem. It tells you the scale factor is 1/2. Well, if my original length of 4 is 4, I multiply that times 1/2. So my new triangle, my smaller triangle, is only going to have a bottom length of 2. 4 times 1/2. And they've already done this in there for you. So that's how they got point F. They just sucked it down and made sure that the new length was only 2, 1/2 of the original. And again, there's a formula for this. You want to try to memorize it. And again, I don't know that that'll even last through the quiz, much less all the way through the EOC. Now it's a little trickier because my other lines are not going along grid lines. But we do what we just said before. We're going to just use left and right numbers and up and down numbers, and we're going to cut those in half. So if my original side, so I'm now talking about from E to D. So my original sides for E to D are 4 and 2. So what would the new sides need to be for 1 and 2, right? So I would just say, okay, well, I need to go from here. And again, not saying this is easy, so you're going to have to practice. So I still need to be going up and down and left and right to create my new point E. So my bottom side needs to be a 1. My other side needs to be a 2. That is how they created E. So again, I took these two sides. Actually, here we can use. You're welcome. So that was the original point E to D. I just created another vertical line and horizontal line that were half of those values. So the left side, again, I can't count diagonally. You're doing F to E now. So the original one, let's talk about that. Oh, 4 up, 4 up. So yeah. So I see, yeah. So again, the original would be 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. So I would take those, cut them in half. So my oh, I already said it.
We went back in the way.
Well, that's because I'm doing something. If I got the wrong information, I got to change it. So the original length of that is 4 and 6. I already really had these 2 points. I really just need to connect them. So now this should be 3 and 2. 1, 2, 3, 1, 2. Perfect. So again, just remember when you have diagonal lines, you can do that and try to figure out how to do it using that. But it's a lot easier just to count two numbers, use left and right numbers and up and down numbers, and then just change those, multiply them by whatever the scale factor is. Little trickier to figure out sometimes where they go, but you don't normally need all of them. You normally just need, if it's triangle, you just need two. If it's a four-sided figure, you'll probably just need three. So try to do now on your own, on your lonesome. Well, the first one's easy. Three. Let's do example 3. A is centered at the origin. Oh, right. But it's centered at the origin, we don't need it. So remember, centered at the origin, we just multiply the scale factor times every single direction, every decimal. That's why I'm giving you that one first. So do example
How do we know?
3. It tells you A says centered at the origin. Is that what you asked?
Yeah, so that.
So again, that was the one where we said, okay, if it's at the origin starting at 0, 0, we don't need to do anything weird. We just multiply the scale factor times every x and y. So this is some stuff you're going to have to keep clear for Monday. Quiz grades are in from last Monday's test. They were low. Some of you are in catch-up mode. You had, no, I don't. You got a lot of these yesterday better be good because you had a lot of practice time last week for yesterday. I can understand last week's quiz being low. We didn't have much practice time. Now it was on rectangles, which you've been doing since you're in 3rd grade. But I can still get that we went kind of fast and covered a lot.
Kind of parts of it.
Yeah, but you know what?
Maybe I do.
When some people didn't understand there's a 90-degree angle in the corner of a rectangle, that's wrong. So go ahead and do example 3, part A. You don't need a figure for that. They actually made B a lot more difficult than I would like them to have made it. I might create one for you, or we might just skip to. Can't do that. I might create one for you. Actually, I'll do that while you're working on this. You don't really need that. Helpful. You should really all be done with the other one by now, if you're doing anything. And do not sit there and do nothing. It's driving me crazy. Literally, if you were paying attention, you would know. So, I'm going to answer that. Yes, you've been yapping. You've been yapping.
Don't you dare, Isaiah.
Don't you even.
Isaiah, what page are we on? Boom! That's simple.
Be your
Yeah, he pays attention. It's really not that hard when you pay attention, people. Right below what I just did. Hey, don't let them bring you down like that.
Let us bring you down.
Well, I do feel like that's happening again, so there are going to be some seat changes in classes. So I'm just waiting to see how this one goes because, again, I get that last week was tough. I'm going to give you a pass on that. If we don't do well on yesterday's, and by we, I mean this group, you won't be sitting.
What about?
They do well. They're all right.
Okay, very well. Oh,
You, well, I'm hoping that's what I'm saying. Hope. I know, that's what I'm saying. Well, but again, I'm giving you a pass on the one that you didn't do well on. And I'll see how you do on the one yesterday, and if it's not good. It's a good one. You told me you had a good note, so I'm hoping that's a good sign. But remember, you all have to be doing well, not just one of you. Because if one of you is distracted, that's not good either. Hold on, I'm setting something up for us to do. Nope.
oh, wait, never mind.
That's an example.
That's all I'm asking. Help. telling her no. That's-
That is completely accurate.
That could be controlled.
Well, not if she practices.
I would think so, sausage.
Oh, I don't want that.
Today, okay.
Again, funny how some people that pay attention know the answers to all the questions you guys ask. All right, what did you get for the answers on that one? That one should have been easy. Around the origin should not be super challenging. What did you get? That's because it should not require help.
There's someone out there.
Need
All right.
help.
Shouldn't require help. We just did it for the origin.
Oh, wait, I got it. Hold on, give me 1 minute, Mr. Gill, I'll do this. Give me 1 minute, Mr. Gill.
Oh, that's right. Well, we got to move on. So again, this kind of stuff that frustrates Mr. Gill. I'm just telling you right now. Again, you're literally multiplying numbers together. And you have a calculator. Don't that around the origin. I mean, I expect all of you to get that problem correct. It's not. I don't even consider it medium difficulty. It is easy. You take all of the values of x and y and you multiply them by a number. You got to calculate it.
Is that what
They're
you're
nothing,
talking
they're
about?
nothing difficult.
Oh, I already know how to do it.
Yeah, around the origin is not difficult. We need to be focused on this one that is difficult, which is what we're about to do right now. So, I'm telling you, this is your pre-image. I want you to create an image, and I'm not going to make them super tough when they're not around the origin. Around the origin is.
You get graphic.
Oh yeah, I do want you to draw this out.
Okay.
I had Greg Pepper out somewhere. Oh, it's over.
Grip paper.
It's pretty.
Really?
Ah, that's not the one I want to grab. That's fine. It'll work for just one second. There. So this is not the graph. It's got a ton of numbers, but you won't use all of them. That's fine. People.
The graph. Oh, sorry, Sherry.
Oh, so. I would say that's bad. All right, so again, that's your problem. Draw out where that is.
What's the
You don't really use x and y values if it's not around the origin. Oh, and then, I didn't finish that. So we'll just keep it pretty simple. Scale factor is 2. Center, I wouldn't say that. So the center of dilation is point A. Is it? We're creating a new image. Center of dilation is A. Scale factor is 2.
So you can't move.
Hey, there's 1 point already. That's how far behind you are. I've been seeing it again. 3 minutes.
Why you think right after you're not thinking 3 minutes.
I was just so proud of you for getting the answer right and yelling at them for not knowing what they were doing.
Wow, you just switched up on me.
So you're glad she yelled at people.
Yeah, because you deserved it.
Oh, thank you.
You guys were sitting there doing nothing. It wasn't even a hard problem.
I was too crazy. You never know.
You
my
were
phone.
not. It literally is multiplying two numbers. Even Chelsea was like, you're multiplying, sorry, you're multiplying two numbers together.
What's crazy? I didn't know what numbers to do that. I didn't.
The only numbers you have, all of them. Every one of them. Every one of them. Only ones you got. Good Lord, it really was not that difficult. Seriously, people. This one's a little different. So we'll wrap it up in a couple minutes. I'll give you a chance. Again, one thing you should be able, well, two things you should be able to tell me. One person already said one of them. So that would be the other one.
Watch this. Watch it. How many squares is this? How many squares?
I mean, yeah, if you're writing, I'm assuming you're putting them on the graph, you would just copy them off. I'm again hoping you guys can pull the X and the Y out from the graph. Although some people can't.
Okay, so
Give you another minute and we'll go through it. What's your? You got contacts now, so
Hands.
what's that?
And this like stand. CJ, they thought it was a good idea and add down protection. So we scanned our hands.
You did it also.
Yeah, because I'm not bad at it.
I feel like you can still write.
I didn't this one bad. Like I cut with this one. The finger. Not much.
Why are you being so
I
hard?
know. We're kind of all wondering about what you're doing.
this line, right?
Somebody did tell me they skinned theirs up a little bit, but yeah, yours are way worse than anybody's I've seen.
Yeah.
All right, so let's go ahead. We got 3 or 4 minutes. What is one thing you can tell me about this? Somebody's already said it. We'll say them both. What?
No, B and C.
What are you talking about?
The thing.
What about? I'm not still in the.
That's the one that we can do.
What are you guys?
Like
What is the one we can do?
like okay, so like we could find the scalar factor, so we're gonna times that by 2, so we can get 6.
So the length. Okay, so the length of side BC is double the original.
Double.
So instead of 3, it's 6. One thing you should know. What's the other thing you know?
A can't move.
A doesn't move. If it is the center of dilation, A doesn't change. So all I'm doing is I'm doubling how far I go down and over to get to B. So if I go down 3 over 1 to create the new B, I'm going to go down 6 over 2. And you'll also notice it should line up. We'll use yellow. So it should line up and go right through the other point, because remember, we're not changing the direction the line goes, we're just extending it. So if you have your point in the right place, it should always go right over the other side. So for C, again, same thing. I would say, well, how far do I need to go from A to C? Well, 1, 2, 3, 4, down 3. So I just double that. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 1, 2, 3. You did it correctly. When you draw a point to A, it should go right over the other side of it. Kind of a quick check that you can do is, I mean, you could almost just extend the lines all the way out and then kind of then figure out what would be 6 down here, right? Because we know this side has to be 6. So between what 2 points do I have 6 units? There's a bunch of ways to do it if you practice it. That's about, I'm not going to probably put the hardest level one on the, you might see on the MC or on the district thing, but to me, that's, we'll see. Oh, so I haven't assigned problems for that because we didn't get quite as far. I will tell you, since we're recording, what they are. So it's on the recording. So I want you to do example 3, part B. which the graph paper won't be big enough, so you gotta, well, actually, that graph paper might be. And then on page 75, 6 through 11. Yeah, 6 through 11. Three of them are center of the origins. Just multiply them. Yeah, 75, 6 through 11 was the second part. We already did 1 through 4. Correct.